First question says, what would the next three terms be? It goes -3, then to 6. Well, what's the pattern? Let's look at that first. Times -2. And then if I times -2 again, that would be -12. Times -2 again, 24. So Skylar, what would be next? What's the next number? -48. Quincy, what would be after that? +96. And what would be next? -192. Perfect. Awesome. So we just multiply by 2 each time to get the next, the next, the next. Multiply by -2. Is this an arithmetic sequence? What do we think? Raise your hand if you think yes. Raise your hand if you think no. Raise your hand if you're unsure. A lot of people didn't raise their hand. The answer is no. And the reason why is because an arithmetic sequence is when you add to get from one number to the next. So arithmetic, we add. But here we're multiplying to get from one to the next. So we actually call this a geometric sequence. But right now we're just focusing on arithmetic sequences. So that's when we add. So that's why the answer is no. Yeah. All right. The next warm-up, we have to graph. So we have y is equal to x minus 2. So let's focus on graphing this one first. What is my slope here?
2.
So remember, y equals mx plus b. 1. If I don't have a coefficient in front of the x, that number would be 1. So my m is 1. So b is -2. So I would graph my y-intercept to my b first. Where would I put a point at? At -2 on the y-axis. And then my slope is 1. How would I show the slope of 1? Perfect. 1 is the same thing as saying like 1/1. So my rise and my run would both be 1. So up 1 over 1, up 1 over 1, up 1 over 1. Once we have a couple points, then we can just connect the dots with our line. So that's the first line, but we have to do the second one too. So in my second line, what's my slope? 2. And what is my y-intercept? 1. So let's plot our y-intercept first. So I cross the y-axis at 1. And then how would I show the slope of 2?
Up 2 instead of right.
Perfect. So I can make it 2/1. So my rise would be 2 and my run is 1. So I go up 2 to the right 1, up 2 to the right 1. Once we have a few dots, we can connect our dots with the line. So there's our two graphs. All right, so let's get started with 4.7. So 4.7, we have piecewise function. So a piecewise function is a function defined by 2 or more equations. Each piece of the function applies to a different part of its domain. So piecewise functions are just pieces of different graphs, but in one. So it's kind of like graphing two different things, but it's just pieces of them. So for example 1, we're evaluating the function. So the steps here is we have to find what piece it belongs to, and then evaluate the x value. So if I have x is equal to 0, so for the first piece, we're just talking about x's that are greater than 0. And the second piece, I'm talking about x's that are less than 0. So what do you think x is equal to 0 falls into? The first piece or the second piece? Is 0 greater than 0, or is it less than or equal to? It's equal to 0, so it falls in the second piece. So that falls into this one. So I have x minus 2. But we just plug in 0 into x, so it'd be 0 minus 2, which would be what? Negative 2. So my answer is just negative 2. For the next one, x is equal to 4. Does that fall into the first piece or the second piece? First, because that's when x is greater than 0 and 4 is greater than 0. So we have 2x plus 1, and I plug in 4 into the x. So 2 times 4 plus 1. Make sure you follow your order of operations. So what do I have to do first? Multiply. 2 times 4 is? 8, and 8 plus 1? 9. Awesome. All right, next we have negative 3. Does negative 3 fall into the first piece or the second piece? Second. Let's see. Is negative 3 less than or equal to 0? Yeah, so it falls in the second piece. So I'm using this equation. X minus 2. So what is negative 3 minus 2? Negative 5. So B is the same thing, but instead of saying x equals, it just says f of x, so f of the number, but this is the value that we're looking at for x. The number in the parentheses is our x. So we keep this the same as x is equal to negative 1, just like we did on the last one. So if I have negative 1, which piece would that fall into? The second one, because the first one is talking about x's that are less than negative 2. So that'd be like negative 3, negative 4. Second one is in between negative 2 and 5. And then the third one is x is greater than 5. So negative 1 would be in between negative 2 and 5. So we're using the second piece here. So I have negative 1 plus 2. Because it was x plus 2, and I plugged in negative 1 into x. What's negative 1 plus 2? 1. For the second one, I have f of negative 2. Which piece would that fall into? The second one. Do we agree it's the second one? Yeah, because the second one says negative 2 is less than or equal to x. So it's equal to negative 2, so it'd fall into the second piece. So x plus 2. So negative 2 plus 2. What's negative 2 plus 2? 0. All right, next I have f of 0. Which piece does 0 fall into? Do we agree that it's the second? So let's see, is 0 in between negative 2 and 5? Yeah, if I put these numbers on a number line, I had negative 2, negative 1, 0, 1, 2, 3, 4, 5. In between negative 2 and 5 would be all of these numbers here. So 0 falls in that category. So we're looking at the second one. So x plus 2. 0 plus 2 is 2. All right, next. I have 3. Which piece would 3 fall into? Second one? Raise your hand if you think the second one. Does anybody disagree? You're right. It's still the second one. Because 3 is right here, so it's still in between negative 2 and 5. So 3 plus 2 would be what? 5. Awesome. right, somebody other than Skylar, where do you think 5 would fall into? Why do you think the second one?
Because it's equal to. Or
Perfect.
less than.
Because it has that less than or equal to, 5 is equal to 5, so it'd fall in the second one. So x plus 2, this would be 5 plus 2, which is 7. And then lastly, we have 10. Which piece would 10 fall into?
Third one.
The third one, because 10 is greater than 5. So I have 4 times x, so this would be 4 times 10. What's 4 times 10? 40. For the next section, we are graphing a piecewise function. So when we graph a piecewise function, we just have to graph each piece separate, and then we take out the portion that doesn't fit. So we have to look at the restrictions here. So we're treating this as 2 separate lines, just like we did in the warm-up, where we had 2 lines. We just graph each one, and then we erase the part that doesn't fit in here. Yes. And lastly, we have to describe the domain and range, but we're going to graph first. So let's start with our first piece. So I'm going to rewrite it down here. X is equal to, or y is equal to negative x minus 4. What is my slope here?
-1.
Remember, y is equal to mx plus b. So the number in front of the x is my slope, so my slope would be -1. What's my b? -4. So start with my y-intercept. Where do I cross the y-axis? At -4, at my b. B always tells you where you cross the y-axis. This is your y. Now, how do I show a slope of -1?
Go down 1 and go to the right.
Perfect. So this is like saying -1 over 1. So it's rise over run, but I would go down 1 and to the right 1. So on my graph here, I go down 1 to the right 1, down 1 to the right 1. You only need a few points, and then just connect your points with the line. So this is our first graph. But for our graph, we only care about when x is less than 0. So looking at my graph, on my x-axis, I'm going to go to where x is 0. Put a line here. This line isn't part of our graph, but just to see it, we go to 0 because we said x is less than 0. That's our restriction that we care about. Less than 0, would that be to the left or to the right?
No.
To the left. So that's the part that we keep. Everything else gets erased. So everything to the right of 0 gets erased. So we only keep where x is less than 0. And then the very last step for this piece is if we have a less than or greater than, at that point, we put an open circle. If it's a less than or equal to or greater than or equal to, we would put a closed circle. So for this point at 0, is it going to have an open circle or a closed circle? Which one? Open, because it's just less than. So less than means I have an open circle. So we would put an open circle. So at 0, I put an open circle, just like that. So looking at the second piece. Here I just have x. So this is y is equal to x. Now remembering our y equals mx plus b, what is my slope here? What's the coefficient? What's the number in front of x?
1.
1. If it's not written there, it's implied that it's a 1. So my slope would be 1. What is my b? 0. I don't have anything that I'm adding after the x, so my b would just be 0. So going to my graph, where do I cross the y-axis? At 0. So I'd put a point at 0. And then how do I show the slope of 1? Perfect. I'd make it 1 over 1, so this would be rise over run. So I go up 1 and right 1. So I go up 1 to the right 1, up 1 to the right 1. And draw my line. Now this is the whole line, but I only care about when x is greater than 0. So I'm going to go to 0. I'm looking at 0 here. Which side is greater than 0? To the right or to the left? The right. The right numbers. All of these numbers for my x's are greater than 0. So I only care about when x is greater than 0, so I'm going to erase the blue line that's less than 0. So we erase everything to the left of 0. Now, at 0 for my second piece, do I have an open circle or a closed circle? Closed circle, because it is greater than or equal to. That tells me I have a closed circle, so it has to be a closed dot there. We fill in the dot. So at 0, I have a closed circle. So my graph looks like this. It's just 2 pieces of each equation. So let's look at B. Again, we have 2 pieces for a piecewise function. So I'm going to treat them separately. I have y is equal to x plus 1. And the other one is y is equal to negative x. So looking at our first graph, y is equal to x plus 1. What is my slope? 1 over 1, or just 1. 1 over 1 will help us when we graph it. What's my b?
Negative 1. Plus. Plus.
Positive 1, because it's a plus 1. So remember, y equals mx plus b. So what would I graph first? The positive 1, I graph my y-intercept. B is where we cross the y-axis. And how would I draw a slope of 1 over 1? Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. We just connect the dots with a line. All right, so next we want to erase half of our graph because we only care about a piece of it. So we only care about when x is less than or equal to 0. So let's go to my graph. I'm going to put a line down 0. Which side is less than 0? The left side. So which side am I going to erase? The right side. Because we only care about when x is less than So we only keep the left side. And now we want to see at 0, am I going to have a open circle or closed circle here? Closed circle. So we just fill in that dot. So it'd just be a closed circle. So that's our first piece. Any questions on the first piece? Ready for the second one? All right, so looking at our second one, I have y equals mx plus b. What's my slope? Negative, we can say negative 1 over 1 or just negative 1. And what's my b? 0. So remember, b is our y-intercept. That's where we cross the y-axis. So where do I cross the y-axis? At 0, because b was 0. How do I put the slope of negative 1 over 1? Down 1 and to the right 1. So I'd go down 1 to the right 1, down 1 to the right 1. And then just connect your dots. Right, now for this graph, we only care about when x is greater than 0. So going to our graph, I'm going to put a line through 0. If x is greater than 0, is that going to be to the right of this line or the left of the line? It'd be to the right. Numbers greater than 0 are to the right. So I erase everything to the left because we only care about numbers greater than. So we keep everything to the right of that line. And the last step is we need to see if it has an open or closed circle. So looking at x is greater than 0, greater than, does that mean it's open or closed? Open. So I'd put an open circle at that point. So our graph should look like that. All right, for C. So we treat each piece separate. So I have y is equal to x minus 2. So this is y equals mx plus b. What is my m? What's my slope? 1. So it'd be like 1 over 1. So this is my rise and my run. What's my y-intercept, my b? Negative 2. So where would I put my first point on the graph? At negative 2. And my slope was 1. We might. So, Marco, how would I do the slope of 1? Yeah. Which direction do I go?
Just up 1.
Up 1 and? To the right one. So up 1 to the right one, up 1 to the right one. Once we have a few dots, we can go ahead and connect our points. So now we only care about when x is what?
Less than 0.
When x is less than 0. So I'm going to go to my graph. I'm going to put a line down 0. Which side would be less than 0?
The left side.
The left side. So I erase everything else to the right. Now at 0, am I going to have an open circle or a closed circle?
Open.
Perfect, because it's just a less than sign. So just less than tells me I have an open circle. So this tells me it's an open circle. So that's our first piece. Any questions there? All right, let's do the second piece. So y is equal to 4x. So what's my slope? 4. And what's my y-intercept? 0. What should I plot first? What point? 0. So I put a point at 0. And now how would I show the slope of 4? Perfect. Go up 4 and to the right 1. Up 4 and to the right 1. So once we have a few points, we can connect our dots. Now, what's the only part of our graph that we care about? X is greater than or equal to 0. So we're looking at greater than. So we put a line down 0. Is greater than 0 going to be to the right or to the left?
Right.
To the right. And which part do we keep? The right. So we keep the part that it's talking about. Erase everything else. Since it was greater than or equal to, does that mean I have an open circle or a closed circle? Closed circle. So we fill in that dot. So this is our graph. So all of these piecewise functions are gonna be functions. If I had a graph that looked like, let's say I had a line here and a line here. These were my two pieces. Would this be a function? Why not? It doesn't pass the vertical line test. Awesome. This would not be a function because my vertical line touches at 2 points. So this is not a function. So all of these piecewise functions are going to be functions. So you won't have any that look like this. They won't be on top of each other. It'll always be one side and the other side. So if you have lines that are crisscrossing, it would not be a function, so you did something wrong. So just keep in mind that all of these piecewise functions are going to be functions. So they will not be one on top of the other.